let's solve the system of equation here. Okay, so this one has three equations and three variables to solve. So x1, x2, and x3. So what I'm going to do is I'm going to solve it by reducing matrices. Okay, so how do I write this? Here, I will write it like matrix first. So the first row, right, x1 and x2. So this is 1, this is 3. So I will write 1, 3. And of course, x3 here, we don't see here, that means it's 0, right? 0 times something is 0. So that is 0. And on the right side, I'm going to write down the value on the right side of the equal sign. So the first row will be 2. So here, 2. Okay, second row, we have 2x1, right? This one's 7x2. So this is 2 and 7. How about x3? Again, you don't see it, that means it's 0. And the value on the right side is 4. Okay, the third row here. x1 is 1 here, right? So 1x1, 1 times x1. I mean, it's 1 times x1, right? x1 is not necessarily 1 because that's what we are trying to calculate. Okay, so 1, and then 5, and then 1, right? So in row 3, we write 1, 5, 1, and the right side is 5. Okay, so that's the matrix. Okay, so first of all, what are we trying to get to now? Okay, so what we need to do is we were trying to do some operations to these matrices, to this matrix, and then trying to get to, let's say, this form maybe 1, 0, 0, and then on the right side a number, and then 0, 1, 0 here number, right? And then 0, 0, 1, and then a number. Right? We're trying to get to this point here. What does that mean? Well, this is x1, right? So we have x1 equal to a number. So we get to x2 equal to a number, x3 equal to a number. Then we basically solve this system of equation here, right? Because we got the value for x1, x2, and x3. Okay, but sometimes you may not be able to get to this form here, right? For example, let's say maybe there's no solution to this system of equation, then of course you cannot get to this point here. But we were trying to get to this point. Well, let's see how it goes here. Okay, so what kind of operation can we do to this matrices here? To this matrix. Okay, so you can interchange two rows, or you can multiply a row by a constant, or you can multiply a row by a constant and then add to another row and then replace that other row, right, with what you just did, right? Okay, so let's start. Okay, by looking at this, what can we do first? Now we can we might be able to make this one equal to 1 right away by doing what? Well, if I multiply this number by -2, then this will become -6, right? And if I add to this row here, it will become 1 here. Well, if I multiply this one by -2, right? Because when you multiply this one by -2, you're multiplying the whole row by -2. And this is -2 plus 2 is 0. Well, that actually does two things for us. Okay, so let's do this, right? We multiply the first row by -2 and then add to the second row, and we will place that to the second row, right? So how would that look like? Let's say here, right? So let's see. The first row will not change. Right? The second row, -2 times 1 is -2, plus 2 is 0. Now, -2 times 3 is -6, plus 7 is 1. Now, -2 times 0 is still 0, right? So 0 plus 0 is 0. And -2 times 2 is -4, plus 4 is 0, right? -4 plus 4 is 0. Row 3 will not change, of course. Okay, next. Now look at this matrix here. What can we do? Now this is good, right? 1, 1, 1, but it's not really solved yet, right? Because I still have a 3 here, a 5, and a 1 here. Okay, so what can I do? Well, maybe we can try to get rid of the 1 here first, right? It's easy, right? How is that easy? Because all I need to do is just multiply row 1 by -1, and I can have -1 offset the 1 here to make it 0, and this is just -3 plus 5 make it 2, but 0, anything times 0 is still 0, so it doesn't change anything. Well, we can definitely have this offset this, right? That's okay. So the next thing we do is -1, right? -1 times row 1, so negative row 1, okay? I just write like that. Add this to row 3, and replace row 3, right, with what I said here. Okay, so here, row 1 will not change. Okay, so row 1 will not change. It's row 3 that will change. Row 2 will not change either. So I can just write this again. Okay, now -1 times 1 is -1, plus 1 is 0. -1 times 3 is -3, plus 5 is 2. Now -1 times 0 is still 0. 0 plus 1 is 1. Now -1 times 2 is -2. -2 plus 5 is 3. Okay. Now, let's look at this matrix now and see what you can do, right, to eliminate the 3 and the 2 here. Okay. We do see that this is 0, this is 0, right? And to get rid of the -3, to get rid of the 3 here is easy. We just need to multiply this row by -3, because at the end, everything else is 0 except for this is 1, right? So I will not change anything here. I will only offset the 3 here, right? Okay, so let's do this. -3, row 2, I add to row 1, and I will place row 1, right? See how it goes. So row 1 will change. -3 times 0 is 0. 0 plus 1 is still 1, right? -3 times 1 is -3. -3 plus 3 is 0. And -3 times 0 is 0. 0 plus 0 is still 0, right? -3 times 0 here is 0. 0 plus 2 is still 0, okay? No, 0 plus 2 is 2, okay? So here, so that's 2, right? Not change. And of course, right, in this operation, row 2 and row 3 will not change. Okay, all I need to do is just get rid of the 2 here. Okay, would that be easy? Yes, it is. I will take -2 times row 2, right? Because everything else is 0. I will only need to change this one, right? Okay, so next, -2 row 2. Add that to row 3 and replace row 3 with this. Okay, let's see here. So that means row 1 and 2 will not change. Okay, so row 3. -2 times 0 is 0. 0 plus 0 is 0. -2 times 1 is -2. -2 plus 2 is 0. -2 times 0 is 0. 0 plus 1 is 1. -2 times 0 is 0. 0 plus 3 is 3. Okay. Are we done? Yes, we're done. We have 1 here, and 1 here diagonally, right? And everything else is 0, and we have a value here. So we're done. What does that mean? Well, this one is x1, x2, and x3, right? And we have the result here. x1 is equal to, x1 is equal to 2 here. That's the value, right? x2 is equal to, okay, x2 is equal to 0. x3 is equal to, what? This is x3, right? That is 3. Okay, so that's the answer. x1 is 2, x2 is 0, x3 is 3. That's the solution to the system of equation here. Now, if you want to verify or validate whether those solutions are correct, you just have to replace or substitute into this x1, x2, x3. And if you get the value here, right, and satisfy all three equations, then you are good. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.